Good day, everybody, and once again we are back together. All right, so this time we are going to be looking at complex planes, otherwise referred to as Argand planes. Right, so by the end of this lesson, I want you to have a thorough understanding in two things, and I'm going to talk about it at length. I want you to understand essentially what is the modulus, of a complex number, right? Of course, in relation to the Argand plane. And I also want you to know what is the argument, okay? So by the time that we are done, you'll have a thorough understanding of both these concepts. Now, let's take a deep dive. And I hope that if you haven't subscribed, you're going to click on that subscribe button and let's get learning together. All right, so firstly, when we talk about Argand planes, essentially you're going to need to remember just a little bit of trigonometry, right? We're going to refer to just a bit of trigonometry, but please don't worry. I will take you through everything that you need to know. Right, so that's so Argand planes are a way of you just knowing how to represent complex numbers essentially in graph form, right? So if you think about us having a Cartesian plane where the x-axis represent the real axis, so we call these the real axes, okay? And the y represent the imaginary, okay? So these are going to be our imaginary axes, right? Okay, so that's the y in this case. Of course, we know in terms of the Cartesian plane, we always are positive on the right-hand side, and that's going to be negative on the left-hand side. And vertically speaking, we know that it's positive as we go up and it gets negative as we go down. Right, now, suppose I've got, a complex number. Say I've got z is equal to 4 plus 3i, okay? Now, what does that mean? Okay, so firstly, we know this represents our real number, and this represents our imaginary number, okay? So this is the imaginary part of z, this is the real part of z, our complex number. So what does that mean? It means that we can now represent it over there. So that means here you're going to have, let's say, 1i, you're going to have 2i, you're going to have 3i, okay? And so on as it goes. And on the x-axis, you're going to have, as per normal, 1, 2, 3, and 4, 5, and so on, right? So what does it mean? It means on the real axis, the number, you're looking at number 4. On the y-axis, on the y-axis, which is your imaginary axis, you are going 3 units up. So in this case, where they converge, right, represents our complex number. So if you look at this is 4 real units, and these are 3 imaginary units. So which means that the complex number z lies on the first quadrant. So this is z is equals to 4 plus 3i. Okay, so this is how you're going to represent it on the Argand diagram, right? Now, I want you guys to please note the following. We also refer to this as the rectangular form, right? I mean, for reasons that you see that it actually forms a rectangle, right? So in this case, we are going to now place it in this particular manner. Now, I want us to talk about the modulus. So what we are going to do now for the modulus is that we're going to take the distance, right, of z from the origin, okay? So if you think about, there's our origin there. Okay, let me just use a different color. So from the origin up until that point z that we have just constructed, right? So this is the distance from the origin, and we write it as a modulus. Now I want you to note, what is the modulus? I did say at the beginning that I want us to understand this word, right? So the modulus is simply that distance that we've got from that point up until, rather from the origin up until you get to that point. But how do we represent it? Okay, so that means that when we're looking at this, remember, we've gone 4 units to the right, we've gone 3 units upwards. So essentially, if you want to look at it as x and y, it means our x value is 4 and our y value is 3, right? Albeit we are going to represent it in this case as a, in imaginary terms and real terms, but you can look at it as x and y. Okay, so your x value is 4, right? There it is over there. And your y value is 3. We did say that is what it represents. So we can use Pythagoras to now determine the distance r, okay? And this distance r is essentially our modulus, okay? So we use the absolute value, okay? So we say that it is the absolute value, meaning that we are always going to represent it as positive, right? So how we're going to get the value of r, so r squared will be equal to x squared plus y squared. That's 4 squared plus 3 squared. And please don't worry about the I representation of I there. Okay, so that's going to be 16 plus 9. This gives us 25. And in this case, because we're looking for the modulus, we are simply going to say, well, r is equal to 5. Now, usually when we take the square root, we say plus or minus. But remember, I did say that the modulus, we will always take the absolute value, meaning that we always represent it as a positive value. So we can say that the modulus of z is equal to 5. Okay, right. So this is what it looks like. That is how you're going to determine the modulus. So simply put, it is just the distance, right, from the origin to your complex number, all right, to where you are going to have it on the Cartesian plane. Now, let's talk about the argument quickly. So how would I then be able to determine the argument of z? All right, so the argument of z, okay, the argument of our complex number. So the argument now is actually the angle, right, between, so what you're looking at there, this is the angle between the real axes. So that's very important. So you always refer to the real axis, and you're always going to look at it anti-clockwise, right? And in this case, we're going to make that from the origin as well. So it is anti-clockwise from the real axis. So that's that angle over there. So how would we get that angle? And this is where I said to you, it's very important for us to remember our trig ratios. Now let me talk about that quickly. So whenever we take a trig ratio of sine, okay, of any triangle, so the sine of any triangle will always be the opposite over the hypotenuse. But if you think of this particular triangle over here, right? So which one is opposite to the angle? So this side over here would be opposite. It's the vertical side. So this is the y value. So this is 3, right? So that's y, which is equal to 3. And in this case, we've got y over r. R is our argument, okay? It's our modulus. So in this case, we know that sine is y over r. But just to remind you as well, we've got the cosine of any angle, right? By definition, what is cosine? That's going to be adjacent divided by the hypotenuse. So in this case, what is adjacent to our angle? So in this case, that's going to be the x side, okay, the real side. So meaning that this is 4 units, right? So when you go that way, that's 4 units long. So that's going to be x over r. Okay. By the way, we know in this case our y value was 3. So that's 3 over 5. Whereas x, that's 4 over 5. But we also know that the tan of the angle will equal to opposite over adjacent. Okay, so to get that, we say, well, that's going to be opposite is the y value, right? That's opposite to our angle. There it is over there, right? Divided by the adjacent, that's going to be the x value. So adjacent just is a fancy word that means next to. So next to the angle, you've got two sides. That is the hypotenuse as well as the adjacent side. Okay, but because the hypotenuse is already given a name, we just simply call the other one the adjacent side. All right, guys. So quickly, I want us to work out what would be the argument. So they would say to us, calculate, okay, the argument. Okay, now how do we write this down? So we say arg z, okay? If, in fact, let's take the original graph that we had. If z is equal to 4 plus 3i. Right, so how am I going to get that angle over there? So I am going to say, well, let's take, we can take any of the trig ratios, right? I've already given you those ratios. And by the way, for the 10, we know that this was y, which is 3, over x, which is 4. So that's 3 over 4. So to get the argument in this case, now if you're given this, now remember already what do I have? I've got the x value and I've got the y value. So I'm going to use the trig ratio that has x and y. And which one is that? That's going to be the tan of theta, right? So which means to get the argument, I'll say tan of theta would be y over x. But what is y? Y is 3 and x is 4, right? Now, to get the angle, theta would be the arctan of 3 over 4. And what is our arctan in this case? Let's shift the tangent of 3 divided by 4. Right. The arctan of 3 over 4, and I get a value of 3.5. In fact, I made a mistake there, 3 over 4. Right, that's going to be 36.887. Okay, now of course it will depend on what your examiner decides as the acceptable decimal, okay, number of decimal points that you can have. In fact, let's just write this as 36.9 degrees. Let's keep it to 1 decimal. Right, so that's 36.9 degrees. So what does this mean? It means that if I'm going to write the argument of z, that is equal to 36.9 degrees. Now, ladies and gents, this can be very, very important because what it essentially does is that I can now give you a diagram, right, and ask you to give me the real part as well as the imaginary part. Okay, now I want us to quickly have a look at how we can then look at it in terms of that. So what it means, ladies and gents, and I want you to please note this. So we're going to take an example in just a few. So what it means is that if I'm given any particular complex number, right? Let's say this is our x value. So x value going that way and y value going that way. And we know this is going to be our r value, right? So remember, z would be equal to x plus yi, okay? Whatever the number of y is, Now, please, ladies and gents, it means, therefore, that if I'm looking at x over r, right, that's going to be the cosine of my modulus, right, of my argument, that is, right? So that means x over r would be equal to the cosine of theta, which is my argument, okay? But I also know that y over r, okay, adjacent, opposite over hypotenuse, that's going to be the sine of my argument yet again. So I can therefore write down x. If I want to cross multiply, x would be equal to r, right, the modulus, the cosine of my argument. Similarly, it means that y would be equal to, again, the modulus, the sine of the argument. Okay, so now I can rewrite. If I'm given the modulus as well as the argument, I can write down my complex numbers. Right, we're going to delve into that. So that means, therefore, z would be equal to r cos of theta plus I times r sine of theta. Okay, right, so that is how we can actually write it down as an argument as well as a modulus, right? Now, in this case, I want us to quickly run. Okay, I want us to take a couple of exercises. Right, so let's take an exercise. And I want you to try it on your own. We'll come back to all of this. I am going to have a separate lesson on the modulus argument form, right, of a complex number. So let's take some exercises. Let's say we've got, okay, so for each of the following complex numbers, I want us to calculate the argument, right, as well as the modulus of it, of course, for you to be able to do that. So we'll round off where necessary. So let's write down, okay, the complex number. So if I've got square root of 3 plus I, let's take another one. Let's say z is equal to 12 plus 9i. C, that's z is equals to 1 plus I. And D, let's take 5 plus 2i. Okay, I want us to go on to the ones that, so if I've got 3 plus 2i, of course, now we are going into the exercises that we had, right? So let's take F. So that's z is equals to 3 plus 2i divided by 2 plus I. Now, I'd want for you to attempt these questions first. I am going to do the first 3, right? And I'm going to allow you to do the rest. And if you want to see the solutions to these, I'm going to actually include the solutions on the membership section. So for those of you that are members, you'll be able to see that on that section. Okay, right. Now let's go for it. Let's take the first one. So what do I have? So firstly, I've got x, which is equal to square root of 3, right? And I've got y, which is equal to 1. In fact, let me write down the complex number first. So z for a, that's equal to square root of 3 plus I. So what does that mean? That means that x is equal to square root of 3. That means that y is equal to 1. All right, so how do I get the modulus first? Okay, so to get the modulus, I'll simply say r squared is equal to x squared plus y squared. And this will be equal to square root of 3 squared plus 1. That would be 3 plus 1. And so r will be equal to the square root of 4. 3 plus 1 gives us 4. And so square root of 4 is equal to 2. Now, I want you to note, ladies and gents, apologies there. Right, I want you to note that r is equal to 2. And so, as a result, now I can write this in the modulus form, right? But before we do that, I want us to find out the argument. So we want to have the argument of this, right? So what is it going to be? Our argument, we said that would simply be, now we've got the r value, we've got the x value, we've got the y value. So what I'm going to do is simply say, now I can take any of my trig ratios. I'm not limited to just taking 10, but I mean, it's easier always to take 10, particularly when you're given the complex number, right? So why? Because you've got the x and the y. And just a hint, just in case you make a mistake in calculating, the modulus, then you can actually just resort to just using 10. So our modulus is equal to 2. Right, so how are we going to get the argument? So 10 of angle theta would be equal to, now please, I want you to note in this case, 10 is y over x, right? So 10 of theta, a y value, that's 1. Our x value is square root of 3. And so theta is the arc10 of 1 over root 3. Or you can say the inverse 10. So I'm going to say shift 10 of 1 divided by the square root of 3. Okay, let's close those brackets. Right, and I get 30 degrees. All right. So what does that mean? It means that my argument, or my modulus rather, is 2, and my argument, we always use argument of z, is 30 degrees. I hope you got that, ladies and gents. Nothing really too complicated about this. Right, so we are going to actually represent it as we should. Okay, right, so we got the modulus as well as the argument. As I said to you, I am going to be looking at just the other representation in a separate video, right? When we talk about the modulus argument form of the complex number. I'm going to be a little bit more elaborate on that. For now, I just want us to calculate. So what about b? Right, let's go for it. So b, we've got 12 plus 9i. Of course, you know what to do, right? Z is equal to 12 plus 9i. So what do? You know how to calculate the modulus. So that's going to be, we might as well say the square root of x squared plus y squared. What is our x value? Our x value is 12, so that's 12 squared, plus our y value is 9 squared, and so that's going to be 144 plus 81. Okay, so 9 squared is 81. And what does that give us? That's square root of 144 plus 81. 81. Okay, that gives us 15. Right, so that's our modulus. So we know that our modulus is equal to 15. But what about our argument? And by the way, I want you to note, I'm going to just quickly, I can use a different formula. I'm not really confined to using 10. Okay, just to show you that we will get the same answer. So for our argument, we're going to say, well, that's the arc 10. All right, and I'll use a different one in just a moment. Right, remember that 10 is y over x, so this is going to be 9 over 12, right? And what would be our argument in that case? That's arc 10. All right, and you get a value of 36.9. degrees. But note, I could have also used a different trig ratio, right, for the argument. So remember that sine, so if I said the arc sine, so the inverse sine, so sine is y over r. So which means y is 9, our r value, it's our modulus, so that's going to be 9 over 15. Right, so shift the sign off, 9 divided by 15. And can you see, ladies and gents, we get exactly the same answer, which is 36.9 degrees. And of course, you could have also used 10, right? Just as long as you get your modulus correctly, you can therefore get your argument also just as well correctly. Right, now for the last one, C, which is Z is 1 plus I. Okay, I'm sure you got the gist of this, right? All right, so try it on your own first. Okay, so how are we going to get that modulus? It's the square root of x squared plus y squared. Got 1 squared plus 1 squared. That still gives you 1. So you end up with the square root of 2. So our modulus would be positive the square root of 2. And so, ladies and gents, how do we get the argument of z? In this case, we are going to say, well, that's arctan of y over x. Okay, that's the inverse 10 of y, which is 1, over x, which is 1, and you're going to get 45 degrees. All right, so that is how you are going to calculate your argument as well as your modulus of your complex number. Right, now what I'm going to ask you to do is complete exercises D, E, and F, right? For those of you that were with us in the first videos when we're doing complex numbers, please refer to those videos so that you know what to do there. Otherwise, I'm going to touch on this section, right? I'm going to complete these exercises on a separate video, but that will be exclusively for our members. For now, ladies and gents, that is how the cookie crumbles. I'll see you again next time, and we'll be talking about the modulus argument form of complex numbers. See you next time. Sharp, sharp.